In this video, let us discuss about the hidden Markov model problem number 1 solution. The first problem is known as the evaluation problem. Given the model lambda, what is the probability of occurrence of a particular observation sequence O equal to O1, O2, etc. up to O2? That is, determine the probability of O given lambda. Our goal is to compute the likelihood of an observation sequence O equal to O1, O2, O3, etc. to O2, OT given a particular model lambda. So let us use the forward algorithm. So define an auxiliary variable, forward variable called alpha, such that alpha t of I is probability of O1, O2, etc. up to OT, comma, Qt is equal to I given lambda. This alpha ti is the probability of observing a partial sequence of observables O1, O2, OT. And at time t, the state Qt is equal to I. That is, alpha t of I is the probability of seeing all the observation up until time t, and at time t being in state I. So the initialization step is alpha 1 of I is equal to II, BI, OI. At each time step, alpha I plus 1, J is equal to Bj of OT plus 1, summation over I equal to 1 to N, alpha Ti Aij, where alpha Ti is the previous forward path probability from the previous timestamp, and alpha Ij is the transition probability from previous state Qi to the current state Qj. Pj of OT plus 1 is the emission probability of the observation symbol OT given the current state J. And the final step is probability of O given lambda is a summation over I equal to 1 to N alpha Ti. So let us explain this one with a figure. So we have to compute the probability of the observation sequence up to time t. So we start from, this is the first time step, second time step, tth time step, t plus 1 times up to capital T time step. So at each time step, the system can be in any one of the state. So there are total n states. So the system can be in any one of the state at time 1. At time 2 also, the system can be in any one of the state. That is what this figure shows. At each time step, the system emits an observation symbol, O1. So this is the O1 is emitted at time 1, O2 is emitted at time 2, OT is emitted at time t, OT plus 1 is emitted at time t plus 1, and O capital T is emitted at time step capital T. So at each time step, each state has a probability value. So that is stored in the variable, forward variable alpha t. So alpha t of 1 means the probability of emitting the symbols O1, O2, etc. up to OT, so O small t. So the probability of emitting this sequence of symbols up to the time step t by the state S1. Similarly, alpha t of 2 means the probability of emitting this symbol, emitting this sequence up to O3 by the state S2. Similarly, alpha t of n means the probability of emitting this sequence up to OT by state n. So alpha t plus 1 of 1 means the probability of emitting the sequence up to OT t plus 1, O1, O2, O3, O4, etc. up to OT plus 1. The probability of observing this OT plus 1, the observation sequence up to OT plus 1 by the state S1 is stored in the variable alpha t plus 1 of 1. Now, the probability of the symbol being emitted by state 2 at time t plus 1 is, so we have the probability up to time t in the variable alpha t. So this probability alpha t plus 1 of 2 is equal to alpha t of 1 into A12, that is the transition probability from S1 to S2, plus alpha t of 2 into A22 into S2. That means the transition probability from S2 to S2, plus alpha t3 into A32, plus etc. up to alpha t of n into an2. So the sum of all these probabilities gives this value alpha t plus 1. So now the probability of emitting OT plus 1 by S2 is determined by, so this summed value alpha t plus 1 2 into B2 is the emission probability of OT plus 1. So similarly, we have the values for all. So we compute the values, this alpha capital T of 1, alpha capital T of S2, alpha capital T of S3, etc. up to alpha capital T of N. So for each one, we will have an alpha value. So that alpha value, so we sum all these alpha values to obtain the probability of the sequence. So that is what the algorithm means. So here, at any time step, alpha of I plus 1 is equal to the emission probability into the summation of the probabilities from the previous step. And finally, at the probabilities, the probability values, we sum all the probability values to obtain the likelihood value. So this is forward recursive algorithm.